Why smart retry? I'm interested in smart retry because payments are one of those areas where small technical mistakes cause real financial damage. Failed payments aren't just a UX issue, they affect cash flow, churn, and trust. What I like about Smart Retry is that it's focused on solving a very specific, high impact problem, not just building generic tooling. I also like that it's early stage because I want to understand the system end to end and not just work on isolated features. What's hard about retrying failed payments? The hard part is that retrying is not just repeating the same request. You have to know why it failed, insufficient funds, network error, fraud rules, expired card, and treat each differently. You also need idempotency so retries don't double charge users. And timing matters because retrying too aggressively can cause more failures. On top of that, you need to balance recovery with user experience and compliance. So, just like with codes, um, you need to handle this exception, especially with the payment systems, because charging twice can lead to legal issues. And you need to like really design it. You need to design it well because having a wrong design could cost a lot of money, such as a fraud, expired card, network error. I mean, the fraud rules. If the card has expired, the bank policies, insufficient funds, and not just that, also the network errors. And if there's like a database storage or corrupted error, you need to know the time to retry because of sometimes it's not really a network error, so you end up requesting something again uh, without like it's just like a delay. So those things exist, so you need to do like a lot of testing to really know if you to really design it well. So basically, it's hard to do this software, but there are techniques like abstraction that people use to be able to get around it. Handling unclear or changing requirements. When requirements are unclear, I focus on clarifying the core goal first, not the implementation. I usually ask what problem we're trying to solve, what success looks like, and what constraints matter most. Then I implement something simple but extensible. If things change, I prefer small iterations rather than big rewrites. So I also write code in a way that it could be extend in the future. I try to prepare for general uh, general application of that code and try to abstract the interface as much as possible and hide the implementation. So basically, I try to have like a deep methods or modules that could be used in the future. So I also try. I mean, since I work with PayPal, there's a lot of things that we did there, such as like um, mitigating fraud, preparing for those cases are actually what I intuitively know because I handle those transaction. I talk to the customer. I know their pain points and how a loss of money uh, affect affect them, and what are the rules that could be implemented for it to be secure. Now, disagreements with the CTO. I try to be very direct but respectful. If I disagree, I explain my reasoning clearly and back it with trade-offs. If the CTO decides differently, I commit fully. I think alignment matters more than being right. So I provide my opinion respectfully. If I disagree, I will provide it and provide my reasoning clearly and back it with my trade-offs. So what happens when a payment fails on the server? When a payment fails, the server should record the attempt, the failure reason, timestamps, and any external provider response IDs. So recording an attempt kind of like intuitively, but declaring or providing the reason, the timestamp, are not kind of like the timestamp is also intuitive, but the reason, the type of reason is not. An external provider response IDs. So you need to like have a unique identifier to that failed payment. It should classify the failure, for example, soft versus hard decline, and decide whether retrying makes sense. So there's a soft versus hard decline that will help you detect if you would retry the charge or charging that card. So importantly, the system should return a consistent response to the client without exposing sensitive details. Idempotency and why it matters. Idempotency means that making the same request multiple times has the same effect as making it once. In payments, it's critical because network failures or retries can cause duplicate requests. So idempotency, basically you're trying to limit. So there's an time frame where you would categorize that request as the same, because network failures or retry can cause duplicate requests. So you need to be able to handle those cases. Without idempotency, you risk charging the customer more than once. Typically, this is handled using idempotency keys stored server side. So it's kind of like the keys that you store in a server side that has like, the time limit, or there's a rules or algorithm that allows you to be able to know if that is the same request or not. Avoiding double charges in retries, you need a unique transaction identifier and an idempotency key per logical payment. So here is the technical details of that. There's a logical payment that you would consider in a kind of like a transaction. You need a unique transaction identifier for that. The server should check if the payment has already been processed before attempting a charge. So the server should check first before attempting a charge to that payment. Even if the client retries, the backend should treat it as the same operation. Cause of failed cards. Common causes include insufficient funds, expired cards, fraud rules, network timeouts, or issuer declines. Some of these are payment failures and shouldn't be retried, while others are temporary and can succeed later. The system should categorize failures and apply different retry strategies. Designing retry safe APIs. I design APIs to be idempotent and stateless where possible. Each request has a unique identifier and the server stores the result of completed operations. If the same request comes again, it returns the previous result instead of executing it again.